Hello calculus students, and especially general seekers of truth. Welcome to the video where we are going to prove the derivative of the sine function. And before we dive into this video, there's a couple precursors or some prerequisites that you should understand. First is the sign of a sum, which is the sine of a plus b is equal to sine of a cosine of b plus cosine of a sine of b. So this is something that's covered in pre-calculus. This is a pre-calc trig identity. Okay. If you are a student at Everest Collegiate and you've taken pre-calculus with Mr. Wen or Mr. Stencil, this is section 5.3 for reference. Okay. You do not need to reprove this rule. You do not need to relearn everything about this rule, but I just want to show you that this rule right here is going to be pretty useful in about 35 seconds. Okay. The second thing that I'm going to point out, which may also be useful, which is this rule that the limit as x approaches 0 of sine of x over x is equal to 1. Okay. So we've also proved this rule geometrically using some fun circles and triangles. So if you don't know what these are, go to the link in the description of this video, look at those other videos first, and then you can return to this one. But without further ado, let's get on with the derivative of the sine function. So we want to take the limit as h approaches 0, f of x plus h minus f of x, all of this over h. And then we are going to apply this particular function, namely sine of x, to the definition of the derivative. Okay. So we had sine of x plus h minus sine of x, all of it over h, the limit as h approaches 0. Now, you see the sine of x plus h here. In order for us to get this proof further along, we have to apply the sign of a sum, because what we have here, sine of x plus h, is in fact the sign of a sum. So this part becomes sine of x cosine of h plus cosine of x sine of h, right, minus sine of x the limit as h approaches 0. So here is where a certain ingenuity is necessary in order to fully complete the proof. And you're not expected to figure this out on your own right at the beginning. This proof was only completed, by someone who's done a lot of work, struggled, and have a lot of trial and error. But I'm going to point out to you that we can do some factoring here. So what we are going to do is a little bit of regrouping. So we're going to take this part and this part and group them together. So the limit as h approaches 0 of sine of x cosine of h minus sine of x, all of this over h, plus the stuff that's left, cosine of x sine of h, all of this over h. Okay. And just continuing on with this proof, now we're going to factor out a sine of x here. So the limit as h approaches 0, sine of x times cosine of h minus 1, all of this over h, plus And now I'm also going to split this limit into the limit of the first part plus the limit of the second part. And I'm going to write it this way: cosine of x times sine h over h. So a few things to point out here, and just kind of really remind you about. The limit here is with respect to h. So if we have an expression that does not contain h in it, it means that the limit doesn't apply to that part. In other words, sine of x here, we can basically treat it like it's a constant, because x has no relation to h. We're taking the limit as h approaches 0. So what we can do is pull this sine of x out to the front. And then what we have left is the limit as h approaches 0, cosine of h minus 1 over h plus, and I'm going to do the same thing here. We can pull this cosine out to the front. Cosine of x times the limit as h approaches 0 of sine of h over h. Well, let's see what we have here. This entire thing is 0. Okay. We've seen this limit before. This sine of h over h is 1. So what we end up with is sine of x times 0 plus cosine of x times 1. This is gone, and what we end up with is cosine of x. And this is f prime. So if f of x is equal to sine, then f prime of x is equal to cosine. So amazingly enough, the derivative of sine is cosine. So these two functions are actually intricately related in more ways than one, not just on the unit circle, not just in calculating tangent, but also in trying to figure out and understand the derivatives. And again, you're not expected to memorize and know this proof off the top of your head or to see how to do it without any practice before. But hopefully you see how these concepts apply and how you can put them to good use. Okay. I have one more problem down here, but I'm actually going to have you do that on your own. And you, of course, could look up this function. That's perfectly fine. You just kind of deprive yourself of the chance to learn and to get some practice in finding derivatives for yourself. Okay. I will give you a slight hint, though, that you're going to have to use the cosine of a sum. That you might have to look up in order to really fully understand what that is for and how to apply that. I'll also spoil the suspense and say that it is not sine. Okay, the derivative of cosine is definitely not sine. So in case you just would like to guess and test and hope you get it right. Okay? So work this out on your own, and if you struggle with it, ask for help. Again, you can also look it up for yourself, but you should at least practice, at least try to work on a difficult problem by yourself. Thank you for watching, and have a wonderful day.